everything you're looking at right now is being calculated 60 times a second with a computer chip, which is in your computer right now. It draws the graphic, which is the GPU, and you can see the interactions here. I can click it here and you can see that it's live. Like this is not a video or a loop. This is interactive. So no video files, no GIF. There's no pre-recorded loop. It moves and reacts because it's running real physics in your computer. When I click, there's a burst of color, and I can also drag it like this. Also, the lighting changes. Here you can see more light, more bright when I do this and when I drag it. So I described this to Claude Opus 4.8 and it built it for me. So now I'm going to show you exactly how you can do this yourself. And then you can use it in your hero section or any section or components that you would like to that fits your website, and you can ship it right now today. So let's understand the basics behind it. So there's a difference between a static page and a page that moves. So an interactive page. So a static page would be just something like it's going to show all the informations and it's all there and that's it. Versus a page that moves, then you can interact with it with your cursor, your hover, your clicks. So every time you click, there's something happening. Every time you move your cursor, there's something happening, and on different components. So whether it's could be a button, could be a like a container. So this makes all the difference. So an interactive page, like a page that moves, that interacts with all your movements, makes all the difference, like I said. So the difference show up in real numbers. It could be like how long people stay on the page, how much they remember, whether your product feels modern, because a static page doesn't feel modern, right? So for a long time, the only way to use this is to ship like a giant video file, which is heavy to load and it's repetitive. It's always the same video, right? As if even right now, if you use a video, then it's going to be repetitive, depending on like the kind of result you want. It could that's what you want, or maybe you want interactions in some part of your website. Could be the hero section or any other page or any other section. So if you're looking for a more generative website, then this is the right option to go with. And when we're talking about video, then like as I said, it's heavy. It's also heavy on the bandwidth. It's heavy on the performance. So the bandwidth is something that you have to look out for, because you can easily bust your limits, your usage, and have a surprise build that would be not a good experience. So the moving website is what we call a real-time computer graphics. So you can come here on this website and you can check on Wikipedia. You can check what this means. So a real computer graphic or real-time rendering is like a computer graphic focused on producing and analyzing images in real time. And that's the key here because it analyzes X time a second. So the term can refer to anything from rendering an application's graphical user interface, so the GUI, to real time, or image analysis. But usually we use it in the 3D computer graphics as it's mentioned here. So typically it's using a graphic processor unit, so the GPU. And that's exactly what we are doing. Everything is rendered in real time because if you interact with a website, there's no other way. You can't do this on a video. And with Opus 4.8 and the newer model, all their intelligence and everything, it makes it so much easier to create all these kind of background animation, this kind of WebGL animation, so much easier, so much accessible to everyone right now, because otherwise in the past you would have to hire someone that is specialized in this, and now we have super smart models that can handle all of this for us. So now we can just ask AI to build it for us, and this is going to have a small file. And remember this, it's a small file compared to a video or that's going to eat up your bandwidth. It's a large file, right? So this is a small file, so you can remember it like this. And this is why it's so much easier to ship at the end. So you will find these kind of animations on the production ready websites on all the platforms like this one, the awards, which showcases all the nominees, the best websites that they have every week. So if you look at here, we can see that, for example, this website here, if we check it and I have it open here on this tab here, and here at the bottom, their footer, we can see that the animations, the same kind of animations is being used. So we have this cursor trails that is following every movement that we have, as well as all the letters animation as we interact with it. So there's no way that you can have this as a video, right? Because you because you won't know any interaction. So this is the same principle, and this is what makes a website really apart from others. So, sometimes people will stay longer with on this website because they interacted with it, they play with it, and the more they interact and they stay with on your website, then the more they are likely to convert. So whatever you are selling or building or trying to expose to the users, then you have more chance of conversions with this. And if we look at other effects that can convert, then we can see here that if we go up, we can see the background changing. That's another um, feature, another effect that people will remember. So you have to have a website that has multiple features or wow moments or just interactions that make them like remember your website. And and if we look here, then there's this kind of layout here that is really nice. And then up here, we have these again, these hover interactions. It's a 3D following our cursor. And up here in the hero section, you can see that it's moving. It's really nice. You can click here and you can change to the next one. So we start with the basics, like this kind of the animations that we had, the fluid animation, and then from understanding the basics, you can build and build up into something like this, which is a motion graphic interactions. So go into motion graphic. So when you're learning the basics, then you can progressively learn other topics and get more into more advanced feature and have and a website like this, which is super beautiful and super interactive and will definitely mark an experience, give an experience to the user that comes on your website. So this effect right here is called a fluid simulation. So more specifically, a stable fluid simulation. So if you want to get more technical, we can come into this page here, which is the Navier-Stokes equations. So this equation is to determine the movement of a fluid or the gases. So this was developed by these two gentlemen. And if you look at all the equations, this is very deep, and most people will never get this deep into this equations just to get a background, a website background. And that's why we have AI, because Claude 4.8 is really great at this, and it's going to ingest this and implement it very easily, because this is not practical, and there's too much topics knowledge to learn to just understand it and just do it and apply it yourself. And that's not the right way to work with AI. So this, most people will not understand this. I don't understand this, and this is why we are doing it with AI, as I mentioned. So a stable fluid is a smart way to solve and a simplified version. So you don't store the actual fluid or you don't store the actual smoke. You just store two pictures and you update them every frame. So the first picture here is the velocity field. So at every point on the screen here, it records different directions things that are moving and how fast. So it's invisible, but it's just motion data. And on the right here is the a picture, like a visual representation of what the die is. So this is just colors that will be displayed according to the velocity. So you can think of this as ink drops into the water. So for every frame, it's going to push this color along with the velocity here, and it's going to fade the color a little bit. And by doing so 60 times a second, then we get a result like this. So the velocity, this is the direction of where the movement is heading. So if I move my cursor in this direction, so this is the velocity. And then you have the die, which is the color behind it. And every time I move something here, you see the movement, right? The velocity. And then the die fades down a little bit and it disappears. And that's what gives the illusion of the fluid or smoke animation. So here again, you can see it here in this plate. So on our screen, we have millions of pixels. So how do we do to get like these pixels to be so smooth and responsive and performant, even though we have millions of calculations that it has to be done? So the way we do this is we need to understand what's a GPU and what's a CPU. So a CPU is like it's a hardware in your computer. It's a worker that's going to work on each task one after another. And in the opposite, a GPU is going to work on all the, for example, the pixels. In this application, we're talking about the background. So for example, for the pixels, it's going to do the calculations. It's going to take this, for example, for every pixel, take this, do this calculation, and all the millions of pixels are computed at the same time. So that's what makes it so smooth. And in the same way, like that's why we use the GPU for training AI or AI inferences, because it's able to do all of that at the same time and not have a choke point. So everything is done in real time, and all at the same time. So in order for your browser to communicate with your GPU, then we use something that is called WebGL. So this is like the communication, the way that your browser is going to communicate and have access to all this to the GPU so that I can use it to calculate all our background animation. And then we have the shader. So those are, well, the shader is a tiny program that is going to run for all the workers. So given for all the pixels, so given the position of the pixel, it's going to decide which color it's going to be. So it's like the program is like a recipe. So following all the rules that we give it to it. So the GPU is going to run this recipe for each pixel all at once, and maybe and 60 times a second. So that's why we got this fluid background simulation, and that's why it's so responsive, it's so performant. So the shader run in a loop. So it's going to calculate everything at once, and then it's going to display the color of every pixel, and then it's going to take the result and give it to the next one. So it's going to take that and recalculate again and again and so on in a loop. So that's what's going to give us the impression that we have for the velocity, for the pressure, the color that's being dragged along and fades away. So those are all determined by the shaders. So writing WebGL and shaders code is really intimidating. So that's why we are using models like Opus. So, or if you use any other provider as well, they are all smart enough and really good at this. So it has a million token context. So this will hold like a single HTML file in its mind, and it's going to be able to edit the file surgically. So it also has the adaptive thinking, so the reasoning. So it's going to reason about the physics, the shaders before writing it. So that's why oftentimes it's going to run on the first try. So the models are also really great at instructions following. So if you have, for example, hard constraints, like, for example, you want it to be a single file, so one file, and you don't want to use any library, so we're going to build our own animation, then it's going to exactly follow that. And it's also very good at creating, completing a self-contained working visual file from a single well-formed request. So when you're working with this model, you become more of a orchestrator. So you direct everything like a director. So you give it, the scene, the kind of visual that you want. You describe it as much, as clear as possible so that it understands, and then you judge it and you iterate on it. So that's why right now, when you do this kind of thing, the most important skill is actually the prompting. So let's get into it. So here's the framework to use when you are prompting for background animations. So first of all, we have to anchor the technique. So this one in particular is the stable fluid GPU approach. So if you don't know the technique, then you can ask the model, because it has been trained on all those kinds of informations, all those techniques. And you can also ask it to make research on the techniques, or make a list of all those techniques, so you can have a preview of all kinds of animations that you wouldn't thought of. So start with this first, so the model is clear on the direction and on the goal. Then we have to constrain the format. So for example, this here, we are using a self-contained HTML file, and with no libraries. So then we have to describe the feeling. This is where you are going to put your taste. So here it can be a cinematic, it can be soft bloom, and the colors, for example, they never washes to white. So this is where you're going to kind of customize it the way that you want, and also and give the animation feelings to the AI, so it can reflect what you have in mind, your thought, your style. And when you have the result, we can iterate on a symptom. So meaning that the important part is to iterate on one symptom at a time, so that it's going to be easier and much clearer. So for example, if it saturates after 10 seconds, then fix the dye buildup. And you can also ask for knobs for config settings. That's particularly important, or very useful when you want to kind of fine tune some of the parameters, so that you get exactly what you want, instead of just prompting and reprompting for one simple parameter, for example. So you can have a control setting, then you can have like sliders or any input values that you are going to fine tune yourself, and you're going to adjust, and then make it so much easier for iterating, and actually to get the perfect kind of style that will fit your work. So again, this is the framework. You are acting as an orchestrator, and we are not getting into any details. So we're just orchestrating, and we're just giving general instructions to the AI. So this is the prompt. This is what it's going to look like. So we are going to ask it to build a real-time fluid simulation as a single self-contained HTML file, no external libraries. So we're telling it what to do, what we need, but we're also telling it the constraints, the format. So one self-contained HTML and no libraries. Then we use the stable fluids GPU approach, Navier-Stokes. So this is where we are going to anchor the technique. So this is all the technicality of that technique. And again, if you don't know the technique, you can ask, you can research with AI, or just ask it to give you a random one. Maybe it's going to be a completely unique background that you can then iterate and to really make it yours. After that, we have the look and feel. So this is where we're going to describe the feeling. So cinematic, near black background, a tasteful palette, soft bloom, ink in water that feels alive. Mouse drag smears dye, click burst, and it gently auto paints when idle, so it's never empty. So then here at the bottom, we are asking it to expose a single commented config object with every turnable parameter. And here, those are the parameters. So this is where we are asking it for the knobs, the configs that we can control and fine tune. So I ran it before, and this is what we got. So we got this beautiful background that is the what we built in the first place, that we showcase. And here you can see that we have the drag, the colors, the swirls, all the physics. And now let's say you want to iterate on this, then we need an easy way to do this and to fine tune it and so that it's going to be seamless when you work with this instead of just prompting, right? So this is where we talk about the config, the knobs, like the commented configs. So when you expose them, it's going to look something like this. So you have all the knobs here and the parameters that you can tweak and really see it affecting your life in your background here. See, so here is like the velocity of the swirls. If this is less and this is more, so it's a bit more chaotic. So you can, and this is applies to this background. So if let's say you have another background, another effect, another technique, then it's going to have maybe different settings, different parameters. So here you can see that we can test it, and it's really, it's working, and it's really great. You can test this one as well. So this is the drag click. You see this one, we can bump it. See, okay. The splat radius, so this is the size of each die and the force. Okay, can test it more here. See, it's way bigger. Die fade. So let's turn this down and test it. And when we turn this all the way up, the color stays more, right? Stays longer. It doesn't fade out as quickly as this. This is great. Bloom intensity, of course. Let's turn it down and now up. So we can see already when we're sliding here, we see the difference. And now it's brighter, more intense, right? So you see, so this is where, so let's say you test it, you want this, but you don't want it to be too chaotic. You want it like this. So it's so much easier to do it this way than just trying to explain yourself, with AI and not having the right vocabulary to do so. So instead, all the configs that are available for this background are going to be exposed here. So it is so much easier to work with. And I highly recommend that you guys do this the first time when you build the background, because this will save you so much time, and it's a matter of taste, right? So you get it to where you like it, and which is going to fit with the product or the project that you're working on. And this will make it so much easier and faster. So this file here also gives you like the prompt and everything here. So I'm going to have this so you can have a look, and it's going to explain how this work in more detail. So this will be available if you want to read about the shaders, for example. This is great for that too. It's not too big. It's just perfect for this particular animation. So once you have fine-tuned and tested like the background and everything is up to your standard and the way that you look, then it's just a matter of building it into a real website. So here I have the prompt. So here for the hero section, so we're going to wrap this flute simulation into a production website hero section, still one self-contained HTML file. So we are going to give it the layout for this website. So you're going to customize this for your own, and then we're going to give it the motion for this. So we have, for example, here a brief intro where the headline rises into place. Keep it tasteful, not flashy. Respect, prefers, reduce motion. And we are going to also address the readability. And if you wish, you can do the responsiveness right now, or you can just try to implement it and then see how it goes. And then once you have your final result, then you can start working on responsiveness, because that's where it matters. Because if you work on it, sometimes when you work on it, it's just like extra steps, more tokens, where it's going to make everything responsive at at the same time, and you're not even sure that you're going to keep some elements or change the structure or the any section. So, uh, may sometimes you work. Sometimes it's just best to uh, take care of responsiveness at the end, but to everyone their own workflow. So once you have this, then I have it here on this is a template that I built on Aura. So you can check it out here at the link here. So this is the website. So we have the hero section. This is a template actually. And this is, we have other interactions with this one, which is the focus, and it's pretty nice. So we can use this technique on other elements other than text as well. So we have other, who followed some kind of motion, some kind of animations, right? So we can scroll. If this is a horizontal scroll, and then this glass effect here. So, you build it and you put the animations that you like, and you kind of make sure that they all mix and blend well together. So this is the template, and you can come and visit my profile here. So we also have paid templates. So you can check this here. And by the way, paid templates, you can totally come and Aura doesn't take any cut from it. So you can actually post your paid template, and then you are going to have 100% of your sales for you, and the platform doesn't take any percentage. You can see all my other templates here. When you build websites, then sometimes it's better, or for inspiration, you come in this template. So sometimes you can start with just a template. It's going to jumpstart your project, and it's going to give you inspiration for sure. So there's a lot of beautiful templates and out here, also from the community. So very, very nice, and very useful. So that's it for this one. This is how you build this kind of background for your own website. And if you found anything useful in this video, then make sure to let the algorithm know by hitting the like and subscribe to the channel, so that you don't miss any new videos. And I'll see you in the next one.